This video is about potential and kinetic energy in a simple harmonic oscillator. So if we start out by thinking about the potential and kinetic energy of our pendulum at different positions, we can then construct graphs of that potential and kinetic energy based on our observations. So if I start out with my pendulum with its maximum displacement to the left, if we think about our pendulum, we know that when it's displaced to the left, it stops moving and it's elevated at some height above the ground. So since it's elevated at some height above the ground, above its resting position, we can say that it has a potential energy at this point. And because that potential energy isn't going to increase any higher past this point, we can say that this is the maximum, the most potential energy this pendulum is going to have. Because the pendulum's just not moving when it's achieved this height, we can say that the kinetic energy of an object that's not moving, is zero. If my pendulum swings, now it swings downward toward its equilibrium position, and arrives at the equilibrium position. At this position, it's no longer elevated above a height, it's now at rest. So we could say that the potential energy at this point in the system is zero. And at this point, because that potential energy had to go into a different form of energy, we could say that the kinetic energy is now at maximum. When my pendulum swings to its rightmost displacement, once again, my potential energy, because I'm now elevated above the starting position, is now once again at maximum, the highest it can be. And because my pendulum comes to a stop at this position, my kinetic energy is equal to zero again. If we were to construct an energy time graph for our kinetic and our potential energy, we would see that when, we can start out with, let's do potential energy in red. So we start out with a maximum when we started swinging our pendulum. Our pendulum went to zero when it reached the bottom down here, and then it returned to maximum again when I completed halfway through my oscillation. So remember that this is only one half of the period of our pendulum's oscillation. So we've only gone from here to here. When we swing back, we're going to repeat the process. So we went from maximum, we return once again to zero, and we finish once again at maximum. We connect our lines, and that gives us our potential energy graph. Notice that my energy graph never goes negative. This is because energy is not a vector like our velocity or our displacement or our acceleration. So our energy values for our potential energy graph or our kinetic energy graph, which we're about to make, are always going to be positive. So I'm going to draw my kinetic energy graph in blue. So we see we start out with no kinetic energy, right there. When I swing through the equilibrium position, when my potential energy is zero, my kinetic energy is at maximum, and when my potential energy is once again at maximum, I swing through and my kinetic energy is at zero again. When we swing backward, so we've completed one period at this point. When we swing backward the process, so we go through the equilibrium position where our potential is maximum again, and we finish our oscillation at the same starting position where our potential energy was maximum and our kinetic energy is now zero again. Connect up my dots, and what we see from our graph, we see that as one type of energy increases, the other type of energy is decreasing. And this makes sense because we know from the conservation of energy that the total energy of our system, our oscillating pendulum in this case, has to remain constant. So therefore we know that energy total always going to be equal to our potential energy plus our kinetic energy. So as one type of energy decreases, the other type of energy has to increase in order to keep everything constant, the energy constant. The other thing we can see in our graph is that when one energy is at maximum, for example, when our potential energy is at maximum, it equals the total energy. So for example, at this position here, our kinetic energy is at maximum, and there's zero potential energy. Therefore, the potential energy or therefore the energy of the system is all in the form of kinetic energy. So when the potential energy is max, it equals E total, and the same thing is true for when the kinetic energy is at its maximum. It also equals E total, because all of the energy is in that form at that position.